absolute value modeling. So y equals the absolute value of x. One thing you might want to do is also have your booklet kind of ready with you, and also the earlier pages like page 3 to 4, because you might be referring to that during this as well. So absolute value modeling, y equals the absolute value of x. Remember the absolute value? Absolute value means whatever the value of x is, make x positive. So the absolute value of x can only be a positive value. That might be a good little note to refer back to in a few months' time, in case you forget how to do this. So in the space below, draw a sketch of this type of function and write out its general equation. See page 3 and 4 if you forgot. So first of all, let's draw up our axes. Let's make a nice little y-axis and an x-axis. Oh dear. Let's fix that up. Do. And what should we label as well? That's right, we should label x and y. Let's not be slack about doing that. Let's make sure to always label our axes. Now looking at page 3 and 4, we're looking for the absolute value function. Absolute value function, where is it? I gave you a little clue too. In the dance, remember in the function dance, it's this one here. So let's see if we can find that on page 3 and 4. Can you find that function on page 3? That's right, it's this one right here. So it's kind of like the line, it's just like this one here, except very much like y equals x. So this little part is the same as that part, but this little part, because y can't take any negative values, it just flips upwards and becomes a positive value. So that's how you end up with this funny little function. And remember, its general equation is this one here. And can you see it here as well? Can you see a absolute value function? Yep. Here's the negative of the absolute value function. So if you did negative x, it would be this one here. Alright, anyway, being lazy. Let's go back to here. So let's just do a few little, marking a few little bitsies on the axes. 1, 2, 3, 4, 5. Let's go 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. So yours are negative and mine. Negative 1, negative 2, negative 3, negative 4, negative 5. Cool. And then now let's plot some points. So we seem to have a little point at 0, 0. A little point here. When x is 1, y is 1. Similarly, when x is 2, y is 2. When x is, great. When x is, oh gosh, something instead. When x is 2, y is 2. When x is 3, y is 3. Oh, this board's a little bit off, sorry. X is 3, y is 3. When x is 4, y is 4. Right there. When x is 5, y is 5. And now, so when x is negative 1, y will be positive 1. When x is negative 2, y will be positive 2. When x is negative 3, y will be positive 3. When x is negative 4, y will be positive 4. And when x is negative 5, y will be positive 5. Because the absolute value of x can only be a positive answer. So let's sketch this now. So sketch it and do it like that. It's a really nice colour. It's a nice green. Go here. Let's neaten it up a bit. It continues to go out. It's a bit hard to draw it. Obviously I didn't draw it very well, sorry. And let's do it again. Along here. Oh, I've got this one. Okay, back to the line tool. Still haven't quite finished it yet. Let's do the other arm. So they connect up. So this is our absolute value function. Hard for me to draw it accurately. This board's a bit wacko. So here's the absolute value function anyway. And it continues on infinitely that way and infinitely that way. It kind of, and notice it sort of has an axis of symmetry, doesn't it? So it seems to have an axis of symmetry cutting through the center. It's not an asymptote. So You might not want to put that in case you end up confusing it for an asymptote. Feel free to leave it off there. Maybe in the description below we'll mention it. The general equation is just generally y equals the absolute value of x in general. That's what that thing is. If you prefer, you can write it up here. Some people like to write it where the function is, so let's do that. Y equals the absolute value of x. It's kind of nice now, doesn't it? What are some features of this type of function? So you could think of it as being similar to y equals x, only all negative values for y have been transformed to positive values. So that's what the absolute value function does. So that's why the left arm seems to flip back up. It's positive values, that's one thing. Try to think, what is the domain going to be? Would you agree that it's going at infinitely in the horizontal positive and negative direction? So horizontally it's spreading out horizontally infinitely. So we could say domain XER. We could also say the range. The range, let's have a look again. Would you agree that it kind of starts at the x-axis and goes upwards? It doesn't seem to live. It doesn't live down here at all, does it? No, it just seems to live up here. So it's y is greater than or equal to 0. Range y is greater than or equal to 0, or wherever the little goofy whacker, the little turning kind of pointy vertex thing is. Yeah, sim to y equals x, and so on. Domain XER, range, that sort of thing. I'm trying to think, is there anything? It's symmetrical. You could say it's symmetrical. It has an axis of symmetry. And now let's do a little diagram to demonstrate that. So they're not asymptotes, it's an axis of symmetry. X, y, here's your absolute value function. It's got an axis of symmetry going through the centre. In that case, the axis of symmetry would be x equals 0. So maybe just write not an asymptote. It's not an asymptote, it's an axis of symmetry. If you can think of anything else interesting to mention, feel free to go ahead and mention it. I'll just kind of move on from now. Explain the meaning behind all of these. So we've got like a little absolute value function. There it is. It's the absolute value of A. And it's at the blood bank. And it's kind of connected. It's giving blood. And so what it's saying is, that's impossible, I can't have a negative blood type. And that's because the absolute value of A, which we can call the absolute value of A, can only be a positive answer. That's why they're saying they can't have negative type blood. The next little poster, so we've got here, we've got the absolute value of 8. So I've got the number 8 in here. It's saying the absolute value of 8 equals positive 8. So absolute values won't put up with negativity. So it says put any value but 0 behind bars. So that's what they've done. They've put any, well, actually notice this is negative 8, sorry. The absolute value of negative 8 is positive 8. The absolute value of positive 8 is positive 8. Put any value but 0 behind bars and the results will always be positive. So remember, if a variable appears inside the absolute value, as in the absolute value of x equals 7, there are two possible values for x. You could have x is 7 or x equals negative 7. And that's because the absolute value of negative 7 equals 7 and the absolute value of positive 7 equals 7. So that's why there are two possible answers. If you are to solve the absolute value of x equals 7, that's why there's two possible answers for x. Because if you had negative 7, its absolute value will give you 7, and if you had positive 7, its absolute value will give you 7. So there's two possible answers when you're asked to solve positive absolute value of x equals 7. That's what that's trying to get at. And this is a little important point. One does not simply change the positive or negative symbol to find the absolute value. So if you do the absolute value of negative 3, of course that equals 3. A common mistake sometimes therefore people think the absolute value of positive 3 is negative 3. It's not the case. Always is a positive answer. It's not that you change the sign, it's just you make whatever the sign is positive no matter what. So the absolute value always is a positive answer. So that's why they're saying you don't just simply change the sign, you just, no matter what the sign was, you make sure the answer is positive. That's what that little meme is trying to point out. It's saying here absolute value is optimism because it's always positive. That's probably pretty obvious by now. Okay, let's move on. But why can't the absolute value be a negative? So why mathematically can't the absolute value be a negative? So the absolute value, or the modulus, that's another name for the absolute value, represents the distance of a number x from 0 on the number line. So as in our universe, distances can only be positive, then the absolute value can't be a negative answer. So here's a little example of one, the number 5. The absolute value is saying how far is the number 5 from 0? So the answer is 5. Similarly, negative 5, it's asking how far from 0 is negative 5? And it's an answer of 5. So the absolute value of negative 5 and positive 5 is 5. So same answer for distance from 0. So the absolute value, so the distance of negative 5 from 0 is 5, that's the blue link there, and the distance of positive 5 from 0 is 5, that's the green link there. So that's why mathematically the absolute value is referring to what is its distance on the number line from the number 0. That's what it's asking mathematically. So that's why technically we can't have a distance of negative value. So hence why technically the absolute value is a positive. Now let's go on to another little example of when sometimes in the exam you're asked to just solve, like do a little bit of algebra to do with the absolute value. Like you might not necessarily have to do something with the function, but maybe you need to substitute or solve using the absolute value. So I've just put a few little examples of that here. So if x equals negative 2, find the value of the absolute value of x. So what you can do is sub in, x is negative 2, that's easy enough. And what's the answer to that? Is it negative 2? No, it's 2. So it has to be a positive answer. So if we put in positive 2 into the absolute value function, the answer still comes out as positive 2. You don't change the sign, you just make sure that your answer is a positive. Next one, x plus 3, absolute value, so negative 2 if x is negative 2. It's not saying x is negative 2 or positive 2, it's just saying x is negative 2. So negative 2 plus 3 gives you the absolute value of 1. Which, as I said, you don't change the sign or anything like that, you just make sure that your answer is a positive. So don't change the sign, just make sure your answer is a positive. If you got a positive answer already, that's great, you just leave it as a positive. If you've got a negative answer, you need to change it to a positive. Here's an example of solving ones. Okay, solving. If the absolute value of x equals 8, there are two answers in this case. In this case, as absolute value of 8, of course, equals 8, and the absolute value of negative 8 equals 8. So we have two answers, x equals 8 and x equals negative 8 are our two answers. And I've got the reasoning is in red. The answers, two answers in this case as absolute value of positive 8 is 8, and the absolute value of negative 8 is 8. So there's two possible values of x that could go into that absolute value sign. Same thing, x minus 6 equals 1. You can possibly get two answers. Answers again as, let's see, so we can say x minus 6 equals positive 1, but it's also possible that x minus 6 could have been negative 1, because whatever the absolute value was, the answer was made into a positive. So it's possible that this thing here could have ended up equaling 1, or it could have equaled negative 1. So what I've done is I've separately set that x minus 6 equal to 1 and minus 1, and we're going to separately solve them. So in that case, x would equal 1 plus 6, which is 7. In this case, x would equal negative 1 plus 6, which is 5. So I've got two answers again. And it makes sense if you plug in, you just check absolute value of 7 minus 6 equals absolute value of 1, which equals 1. Absolute value of 5 minus 6 equals the absolute value of negative 1, which is 1. So that's what I just did then to check. I just checked my answers by doing that. So I'll get rid of that. Just trying to point out to you that you can get two answers when you're solving using absolute values. So let's see, just looking at the two graphs again, like we mentioned a little bit before, what similarities, differences do you notice between the graph of y equals x and the graph of y equals the absolute value of x? So of course here is y equals the absolute value of x. This one here, in case you're not sure. That one. And here is y equals x. Okay. So you can say they both have the same right arm. So they both have the same right arm, which I'll kind of point out in yellow. Same right arm. But their left arm is different. Is different. So by the left arm, I mean this one here. So you see the left arm is different. The left arm of y equals, y equals the absolute value of x is the left arm of y equals x reflected across the x-axis. Back to symmetry again. Just trying to remember what reflections are. Like a mirror image. So the two purple left arms are kind of mirror images of each other. If I took the one on the left and I reflected it across the x-axis, remember the x-axis is this thing, that was my mirror line, then I would end up with the same purple as the purple right arm on the right. Anyway, just trying to connect it a little bit to, what's his name, trying to connect it to symmetry. So they have the same domain. That's one other thing you could say. The same domain. So they both spread out infinitely in the horizontal direction, left and right, which is XER. The ranges are different. They have different ranges. So the one on the left just, as you can see, it's a linear one, so just one on the left is XER, no, sorry, I'm saying YER. Whereas the one on the right, it's y is greater than or equal to 0. And y is greater than or equal to 0. So this one was for y equals x, and this one was for y equals the absolute value of x. And that will do, that's plenty of info. Let's do a few little examples. So you're asked to draw graphs of the following. We know what the basic y equals absolute value of x is, but if you've got y equals absolute value of x plus 2, it's the same as, I'll just say, it's the graph of y equals the absolute value of x, shifted vertically 2 units, so upwards. So instead of it being here and going like this, every little point's going to shoved up 2 units. So instead of being here, it's going to start up there. 2 units. The point 1, 1, which would have been there, it's going to be moved up 2 units, so it'll be here. The point negative 1, 1 would have moved up 2 units to be here. So the point 2, 2 would have moved up 2 units to be here, and so on. 3, 3 would have moved up 2 units to be here, and so on. And so let's draw a line. Use a nice line drawing tool. Okay. Up there. And going up here. And it's going out infinitely. You can draw the arrows if you want, it's up to you. It's still got an axis of symmetry through x equals 0. Whereas this one here is the graph of y equals the absolute value of x, but shifted horizontally, similar to the reciprocal function, how the way that would shift. Horizontally, 1 unit. Remember, the horizontal shifts in the opposite direction to what it says. It says plus 1, so it shifted 1 unit in the opposite direction to the left. So vertical shift follows kind of the sign. The horizontal shift is the opposite. So normally it would be, the little points would be at 0, 0. So if it's moved 1 unit to the left, remember it's the opposite sign to what it says there. So it's moved to here. So instead of there, it's moved to here. So here, everything's kind of moved a little bit to the left. There's no dilation factor or anything. So just go straight to drawing the little thing. Here we go. Here we go. If you want, you can put your little thingamajiggies, little arrows. And notice it's got an axis of symmetry, but this time the axis of symmetry would be through here. So it would be an axis of symmetry of x equals negative 1, if you were to ask what its axis of symmetry is. So maybe you want to say that. Axis of symmetry at x equals negative 1. Whereas this one had an axis of symmetry still at x equals 0. So vertical shift doesn't affect the axis of symmetry, but horizontal shift does. And yeah, draw graphs of the following. This one's got a bit of a horizontal and a bit of a vertical shift. So you can say shifted 4 units downwards, because it follows the sign for the vertical shift, and for the horizontal shift it's the opposite sign. So shifted 2 units to the right, because if it's to the negative direction it goes positive. X direction, so to the right. Shifted 4 units downwards and 2 units to the right. So remember the little vertex would have been there, or the little vertex, a little kind of point would have been there. So instead go 4 units down and 2 units to the right. So each point you would have plotted, go 4 units down and 2 units to the right. and so on. So from this one, this would have gone 4 units down, 2 units to the right, so it's moved there. This little point here would have gone 4 units down, 2 units to the right, so it would have moved there. And so on. This little point would have gone 4 units down, 2 units to the right, so it would have moved there. And so on. You can probably see a little pattern. It's pretty easy to draw the absolute value function. Let's draw in our lines. Draw the arrows if you want. So everything's shifted 4 units down and 2 units to the right. So the axis of symmetry is at x equals, try to think, axis of symmetry, it's going through here, isn't it? So axis of symmetry at x equals 2. And the next one, y equals, and notice it's a negative this time, so this is important. If it's negative, then at the front of the, if there's a negative at the front of the absolute value function sign, then it's going downwards instead. So it's kind of flipped, which is all a bit messed up. So we can say because of the negative, it's inverted. So flipped upside down. Because of this, it's shifted. There we go. Just pause for a second. Okay, I had to just pause and close the document and open it again because it froze on me. So this one, it's because of the +4, it's shifted 4 units. Remember, for the horizontal shift, it's always in the opposite direction. So opposite direction, it's not going in the positive x direction, it's going in the negative x direction. So 4 units to the left, or you could say in the negative x direction, which means to go to the left because of the plus. And because of the +2. Remember, vertical shift just follows the direction of the sign, so positive 2 units. So shifted 2 units in the positive y direction. Up, so in that case it's upwards. So you could say in the positive y direction instead. I'm just going straight to saying it's upwards. So the little turning point, the little kind of point is, instead of being a 0, 0, it's gone 4 units to the left. So instead of being here, it's gone 4 units to the left and 2 units upwards, so it's moved to here. 4 units to the left and 2 units upward. This little point that would have been here has gone 4 units to the left. And normally it would have gone to 4 units to the left, and normally it would have gone up to here, but it's down, it's because it's of the negative, it's gone down here instead. Because it's going downwards. This little point here, 4 units to the left and 2 units upwards, instead that would have been here if you flip it upside down. Again, if you're really in doubt, you could just try substituting in values of x and then just working out coordinates and plotting it from a table of values. That would be totally fine. You've probably seen a little pattern now. No dilation factor or anything, so you don't need to worry about whether it fits or not. Okay. Nice. And where's our axis of symmetry? We have an axis of symmetry. Don't need to write this, but it's just interesting. Axis of symmetry at x equals -4. Notice it kind of goes through there. So axis of symmetry at x equals -4. If you're not sure, you could try doing it on your graphing calculator. So grab out your graphing calculator, let's try this out. So go on, let's do a graph. So y equals. Okay, so we've got to enter in, for example, if you just wanted to do the absolute value of x, that's easy. So you might want to see, it's already set up as y equals, that's all good. So if you can see this little button next to the 9, if you open that up, You can do all sorts of things. You can make fractions, you can make exponents, roots, and all that kind of thing. It's a little one-stop shop for doing annoying little fiddly mathematics. So notice that, oh, let's see that one there, I already had it selected. Which one is the absolute value? Absolute value is this little one here. So if it doesn't click, just click it again. Imagine I wanted the absolute value of x. Enter. There we go. Done. See my absolute value of x. Awesome. If I want to do a slightly different one, I could enter in. Remember, we go to here, select the absolute value. Actually, I want the negative of it first, don't I? So I should put in the negative, because I'm about to do this one right here. The negative absolute value. Enter in my absolute value. And we should have x plus 4, because I'm doing the one we're just trying to do now. Arrow out of there. Plus 2. Have a look, just check did what you type make sense. There it is. So see, it kind of looks roughly the same. So that's a way you can quickly check your answer and see here's my equation there. Pretty groovy. Now let's see some different examples. So write equations for the following graphs. So they all seem to be absolute value functions. That's easy enough. I tend to kind of look to think, what's happened to this little baby? So this little point here, has it been, so it's the same as, so it's the graph of y equals absolute value of x, and it's just been shifted 1 unit upward. So try to think, how would that equation look? The equation for that might be f of x, or y equals the absolute value of x, and because it's 1 unit upwards, is plus 1. Okay, that's easy enough. Give you a nice easy one to do first, because it had only moved vertically, not horizontally. Then the next one, it's been flipped, so it's going to have a negative at the front. So it's had lots of things done. It's been flipped, which means it's going to have a negative out the front. It's also shifted 1 unit upward. I tend to look at again at this little point here. It's shifted 1 unit upward, and oops, right, yes, let's do it like that. Oh gosh. So shifted 1 unit upward and shifted 1 unit to the right. So meaning that we've got a negative in there. So our equation might be something like this. Y equals, because it's flipped, we've got the negative and absolute value of x. And it's shifted 1 unit to the right. So that's in the positive x direction. So we should have minus 1 here, because remember, for the horizontal it's always the opposite. And because it's shifted 1 unit upwards, we've got a plus 1 at the end. Okay. So I've tried to colour code that. So notice I've described my vertical shift in green, I've described my flipping in blue, and I've described my, this one was just y equals, so just part of the regular function. And I've described my horizontal shift in terms of purple. That helps. The axis of symmetry is still at x equals 1. The one beforehand is at x equals 0. Now that these babies. So this one, it's had a few things done to it. It's been flipped. So it's going to have a negative out the front. So we already know y equals negative. And then start to open up the absolute value. X. And it's this little point here. It's exactly the same as the one I did over here. Dude, how boring is that? Okay, so let's make a new one. I'll just make it slightly different. How can I make it slightly different? I could change the axis scales. Let's just change the axis scales, that'll make it easy. 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. Negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 2, negative 4, negative 6, negative 8, negative 10, negative 12. Hasn't changed it that much, but gives us something slightly different. So it's shifted 2 units upwards, so in the positive y direction, and it's shifted 2 units to the right, so in the positive x direction, so the opposite side of the bracket. So in here, 2 units to the right, so I should have -2 here, because it's the opposite for the horizontal shift, and for the vertical shift it follows the right sign, +2. I'm going to try to make it slightly different for you. Didn't mean to put the same one there, sorry. Next one at least is different. And what's really not exciting is that I also included this here, so let's pretend that's not there. It's on your copy, when it's printed out, hopefully it's not on there. Great. Okay, it's not flipped, so you might want to make a note of that if you want. So it's not flipped, so no negative. The shift, so it's been shifted 3 units upwards. That's one thing that we can note. It's another thing we can note in terms of horizontal shift. It's shifted 1 unit to the left, so in the negative x direction, which means we put +1 in the absolute value function. So it's y equals absolute value of x, because it's to the left in the negative x direction, we need to put +1 here. So remember it's the opposite. And it's gone 3 units upwards, so +3. Okie dokie. And that's the end. Thank you very much.